Okay, here are solutions for perfect problem 2. No, perfect problem 3. For, what is this, Math 243. Okay, the basic idea is we're given a bunch of data and asked to do stuff on it, asked to answer all these questions. So we're given coffee sales and the temperature that day. I think we saw this before. Our explanatory variable will be the temperature, and our response variable will be the coffee sales. It makes sense that temperature could affect sales. It doesn't make sense for sales to affect the temperature. So anyways, these are my x's, these are my y's. So the first thing you want to do is put all that data into lists. I already did that because I didn't think you wanted to watch me put that in. So I put my y's are all these guys. They're in L1, and my x's are in L2. So I have to make sure I remember that my x's are actually in L2 here. First thing it wants me to do is to mention and interpret r squared. Okay, to get r squared, you go under stat, and then calc, and then linear regression, ax plus b. And then what I have to do is tell it where my x variables are. My x variables are in L2, so I'll hit second and then 2. And then where my y variables are, they're in L1. And then if you want, this part's optional, you can save your least squared regression equation in case you need it later on, like if you want to view it in a scatter plot. So I'm going to go ahead and do that. I'm going to put in another comma, and a third input I'm going to put in y1. And I find y1 under this variables menu. So hit this variables key, and then go over to y variables, and then function, and then y1. And so what that says is linear regression. Here's your x values, here's your y values, and here's where I want to store the linear regression equation. Anyways, you do that, and what it tells you is that r squared is equal to 0.819. It's pretty good. 0.819. So what that tells me, maybe so, 81.9% of the variance in my y value in coffee sales is explained by temperature. In other words, there's probably a lot of things that affect how much coffee this place sells, but 81.9%, almost 82% of that variance is just due to temperature. It's a pretty big number. I mentioned an interpretation, I guess I did that, a residual plot. Okay, so to make a residual plot, it's a plot, so it's under stat plots. Well, yeah, I think we're fine. Okay, so it's under stat plots. I'm going to hit second and then stat plots to get into my stat plot menu. And then I'll go into the first one, make sure it's on. And then for the type, I'm going to select the same type I've seen before, this scatter plot. And you might be like, wait, I thought you said residual plot, not scatter plot. Right. To make it a residual plot, what you do is for your x variables, you still tell it your x variables, which I put mine in L2. But for my y, on my y-axis, I don't want to list my y variables. I want to instead list my residuals. And residual is something that's in here. If you hit stat, no. If you hit variables, no. If you hit, oh, it's under list, that's right. Okay, so if you hit second and then stat, so I was kind of poking around the menu, I couldn't find it. All you have to do is hit second and then stat, and that gets you into this list here. And the seventh thing on this list says resid. So that's what I want to select and hit enter. And then that will pop up here for my y list. So what this is saying is kind of make a scatter plot, but instead of graphing the y variables on the y-axis, graph the residuals. And we can look at that if we hit zoom and then zoom stat, the 9th thing on the list. And we get this residual plot right here. So my residual plot, if I was going to sketch one. Oh, so let's see. My first one is kind of somewhere up here, and then I got one somewhere down here, couple in here. And then I got the rest of them are up top here. So these are my residuals. Here's my residual plot. an analysis of the residual plot, identifying any possible problems with using the least squared regression line. So the residual plot, these dots should be completely random. There should just be dots above and below, no patterns going on whatsoever. I think there's a pattern here. It might be a little bit hard to see, but we start out above the line, and then we drop down and go below for a little while, and then we come back up and go above for a little while. So we're above, then below, then above. Kind of looks like we have a pattern. We have patterned residuals. And what that tells us is that non-linear regression may be appropriate. So there's two problems in our class that we recognize from a residual plot. One is heteroscedasticity. When these start out close to the line and they end up far away from the line, it's non-constant variance. But that's not what's going on here. The other one is when you have a pattern in your residuals. Instead of just being completely random, there's kind of this pattern going on here. Above, below, above. So I call that pattern residuals, and when you have pattern residuals, you say nonlinear regression may be appropriate. And then finally, I want to draw two scatter plots. Okay. My scatter plots on my x-axis, I want the temperature to go up to almost 100, 92 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then my coffee sales, they go up to 100 also. You have some choice in what you do here. My lowest coffee sale is 45, so I might just start out here at 40, 50, 60, 70, 80, 90, shoot, 100. 40, 60, 80, 100. Good enough. And then I can sketch my scatter plot on here. And you can either do that by looking at the data itself or having your calculator do it for you. If you go under stat plot, enter. And kind of the same thing we did for our residual plot, except instead of having the residuals on the y-axis, now we want our y variables to be on the y-axis. And our y variables, I put them in L1. So I'll hit second one, and then L1 will pop up here. And what you'll see is that when I do zoom stat, it's going to give me both my observations and the least squared regression line, because earlier I saved my least squared regression line. If you hit y equals, you'll see this least squared regression line in here. That was that third input I did when I did the linear regression, when I said save it as y1. That's where it pops up there. So that's why this line appears here. I can now try to graph this data best I can. I don't know how much I care. Sure, why not? I'm going to do them close to right. So my first observation, do I care? I don't care. You guys can do whatever. No, I'm going to make the solutions correct. Sorry, I keep going back and forth. I'm going to actually do this. So temperature is 30. I get 100 coffee sales. So let's see. Here's 10, 20, 30. Here's 100. And then my next observation here is 35. I get 80. So 35, 80. And you probably don't want me to watch me put all these dots down. So I'm going to pause this video. Kind of tried to draw what's going on here. I copied all my points down and then tried to draw the least squared regression line. Got something like this. But maybe what you can see out of this is what we found earlier about the pattern residuals. It doesn't look like the line's a great fit for this data. I mean, it's all right, but we're kind of above the line and then below the... To me, it looks like a better fit for the data would kind of be this curve that this mouse is outlining here. So that's why nonlinear regression may be appropriate. That's kind of what this residual plot is showing. And then the last thing it wants me to do is create another scatter plot, but this time exclude that first observation. So what you can do is if you go into your data here, we want to get rid of this 100 and this 30. And I can do that just by hitting delete. So now I have 9 observations in both of them. So if I go through my exact same steps, stat, calc, linear regression, L2, L1, you might be wondering why I'm doing this again, because it doesn't ask for R squared or anything. Well, it's because I want to save the new linear regression into y1. So I'm going to hit variables, y variables, function, y1. And Now when I hit enter, it's going to save the new linear regression model, this guy right here, into Y1. So if I draw this guy over here, maybe I'll try to use the same scales. So it's 40, 50, 60, 70, 80, 90, 100. Pretty messy, but hopefully it's easy enough for you guys to follow. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm only excluding one value. I'm only excluding this guy right here. So it should look pretty similar, but I think what you'll see is if we go up to stat plot, plots on, and we put in all this same information, L2 and L1, and then graph it, we'll get a slightly different looking line. Because now we don't have this observation right here. So what we now get is a line, if I hit this trace key, that's lower. The y-intercept is now 92-ish. So instead of intercepting over here at over 100, now we're down here at in the 92 range. Maybe I should do this in red. So what ends up happening is the line ends up being a better fit of the data. Jeez, that's supposed to be a straight line. I know it doesn't look like it. But all of our data points end up being really close to the line. Let's see, our first one is 1, 2, somewhere in here. Oh, and our first one is just above the line. So our first one is here, and then there's one right on the line, and a couple there, one there, one here, up here, down there, whatever, close enough. So draw 2 scatter plots, one with all the data and one excluding the observation on the 30-degree day. For each, calculate the least squared regression line and use it to determine if the 30-degree day is an influential observation. So I should have been writing down my least squared regression lines. I can view them here. Actually, what I can do is look and see what I got here. Over here, my least squared regression was negative 0.506 x plus b plus 92.6. That seems like plenty of decimal places. And over here, I guess I don't have it written down anymore, so I'm going to recalculate it real quick. I'm going to put that observation back in. So when I had that 100 as my first observation, and then over here I'll insert, what was it? 30 was the temperature. And then I'll calculate my linear regression one more time with L2 are where my x's are and L1 are where my y's are. This is just redoing this so that I can get this equation here. Y hat is negative 0.668 x plus 104. So I would say note the significant change in the least squared regression line. Right, this equation is quite a bit different from this equation. And when you have a significant change in your least squared regression line, so that observation, the 30-degree observation, is considered an influential observation. And all that is saying is it's influential in that it has a big influence on what my least squared regression line is. If I got rid of, say, this observation, it probably wouldn't make much of a difference at all. But getting rid of this observation really affects my line. So it's an influential observation. That's all I was trying to get at there. That is the end of this example.